Hello everyone, welcome back to the coding part of this video. We are now going to be moving on to the activity in which we are going to help a company predict which customers they could target on, because some of them are loyal customers, some of them are new customers. So we are going to give a helping hand. So let's get started. The first code is to do the EDA and import the library. So we're going to import pandas as PD, read the data set, and store it in a variable called retail_df. Now we're going to print the first 5 rows, print the missing values and how many are there, and then drop the columns that have a missing values and print the dimension and columns and rows. And when we run our code, this is our output. Now our next part is to create a new column called monetary. So retail.df monetary is equal to retail.df quantity multiplied by retail_df unit price. So monetary basically means quantity multiplied by unit price, which equals to monetary. So we're creating a new column. Now we're going to create a new variable, group df is equal to retail_df group by customer id monetary dot sum. Now we're going to do it again. Group df is equal to group df reset index. So now we're going to reset the index and see whether the computer understood the code, and we are going to print the first 5 rows. As we can see, this is the customer id and this is monetary. So for the first customer, he has 346, and let's move on. Now we're going to create a new column called frequency. So frequency is equal to retail_df dot group by customer ID, invoice no, and count. It's a bit different than monetary. So frequency is equal to frequency dot reset index. Here we're going to reset the index again, and the columns of frequency are customer ID and frequency. And we're going to print the first 5 rows. So means frequency is how much time a customer has visited. So the first one has 12 times and 73 and 1. I think this customer should be targeted. And the fourth one. Now we're going to create a new column, recency. And we have to do it 2 times. So number 1, we're going to convert to date time. So real_df invoice data PD to data time retail df. We're gonna print the date. So it's day, month, year, hours, and minutes. Now we're going to compute the difference. So retail_df diff is equal to max. So the maximum function and the minimum function we're going to use here. So retail_df invoice data is minus retail_df invoice data. Now what we're going to do, we're going to do it. Now the last purchase is equal to retail_df dot group by customer ID diff minimum. Now the last purchase is equal to last purchase, resetting the index now, and we're going to print the head. So this is the customer ID and the difference. It's 1 day, 19 hours, 25 minutes, and so on. So the difference, it's the difference between the time there was it. Now we're going to merge the two dfs, means data frame. Now new df is equal to pd.merge group df frequency on customer id how inner print new df.head. Now we're going to merge the third data frame, and rfm is equal to pd.merge new df last purchase on customer id and how inner. And now the columns of RMF is customer ID, monetary, frequency, and recency. And number of days only for recency is RMF recency is equal to RMF recency dd dot date. So we're now going to print RMF dot head, and this is our output. Now we're going to import few libraries. Import matplotlib.pyplot, sklearn.preprocessing, import scanner scaler, sklearn.cluster, import k-means, MLP toolkits, plot treaty is equal to access treaty, and numpy as np. So now we're going to do the standard scalar code, which is scalar is equal to standard scalar. Now rfm underscore df underscore scaled is equal to scalar fit transform rfm monetary frequency and recency. Now we're going to do the same variable here, which is equal to pd dot data frame rfm df scaled. Now RFM underscore DF underscore scaled dot columns is equal to monetary frequency and recency. RFM underscore DF underscore scaled dot head. Now we're going to print the top 5 rows, which is our output. Now we're going to train the k-means with clusters. So k-means is equal to k-means and clusters tree max iteration 50. Now k-means dot fit rfm underscore df underscore scale rfm df scale cluster id k-means label and print rfm underscore df underscore scale head. This is our output after we trained it. Now we're going to go to plot the clustered graph. So fig is equal to pld.figure, fig size is 6 and 6, and ax is equal to fig dot add subplot 111, and projection is 3D. So we're going to make a 3D graph, 3D clustered graph. So ax dot scatter rfm RFM-DF scale frequency, RFM-DF scale recency, RFM-DF scale monetary, lines width is 1, alpha is 5, edge colors is black, and 100, and the S is 100, and C map is spring, means the colors. We're going to go with the theme spring. And RFM.DF.scale is equal to cluster ID. Now we're going to set the X label to frequency, Y label to recency, and Z label to amount. Z label is here because we have our 3D projection. Now PLTs.show, and this is your graph. And here we have it. As you can see, this is X label, this is Y label, and this is the Z label. Amount is just hidden somewhere. So guys, thank you so much for watching this video. If you had any queries, please do let me know in the comments. I will try to resolve them. So I'll see you in my next video. Bye.